So we're gonna click on Unit 9 Vectors. On Monday, April 13th, we're supposed to do Intro to Vectors in component form of vectors, magnitude of vectors. Let's click on component form of vectors. So a vector is array. It has an initial point and a final position, final point. Um, so here's an example. Find the component linear combination form and the magnitude of the vector. So on any on a surface, two-dimensional surface, uh, this would be the initial point at 0, 0, and then it would have a terminal point, and let's say it's 3, 4. So the ray actually goes from 0, 0 to 3, 4, and so there's the ray. What we want to do is find the components, the x component and the y component of this vector. And how do we do that? So there's the formula for it, and the component form of vector formula is this. The vector will equal to subtract the x values, comma, subtract the y values. Make sure you know that the x2 is always the head of the vector, and the tail is the x1 component. So in this situation, it is going to be 3 minus 0. And for the y's, it'll be 4 minus 0. So 3 minus 0 is 3, and 4 minus 0 is 4. So the vector, the components forms will be 3, 4. There's another way of saying the same thing, and it's called linear combination form of a vector. And basically what you're saying is that you're moving in the x direction, which is the I direction, 3 units, and in the j direction, which is the up and down direction, the y, 4 units. And so the answer would be linear combination form of a vector is going to be 3i plus 4j. Next, what is the magnitude of the vector? Which is actually the length of the vector. And the length of the vector, as you should probably see, is that's a 3, 4, 5 triangle. So the length of the vector is going to be 5. Another way of doing it is by doing the Pythagorean theorem and saying that the vector, magnitude of the vector, and it's done by signifying that with these like absolute value signs, that it is the magnitude of the vector. Just plug in the x value, the y value, work it out, and it turns out to be 5. Here's another vector. The initial point is negative 3, 2. It will be the negative 3, 2, and then the terminal point will be 4, negative 1. We want to find the component form of the vector, the linear combination form of the vector, and the actual length of the vector. And basically we do it just the same as we did the other one. X2 would be 4. So really it's going to be 4 minus a negative 3, which will be 7. And then you have negative 1 minus 2 is negative 3. So it's 7, negative 3, the component form of this vector. Same thing, we're talking about the linear combination for the vector, which is going to say that it's moving 7 units in the I direction and negative 3 units in the j direction. The magnitude of the vector, again, is basically the Pythagorean theorem. There it is. Plug in the numbers, work it out. You get 7 squared is 49, negative 3 squared is 9, 9 plus 49 is 58, square root of 58. Okay, so you can go back to the PowerPoint presentation and work this one out on your own. I gotta move on. How do you show that two vectors are equivalent? So in this situation, it says to show that the vector from R to S is equivalent to the vector from P to Q. So basically, we're going to do the same thing we did in previous. We just got to do the find actual component form of the vectors. So let's do RS first. So negative 4, 2 goes to negative 1, 6. So you're subtracting the x's and then subtracting the y's. So negative 1 minus a negative 4, that is 3. And then 6 minus 2 is 4. So it's 3, 4. So the component for the vector is 3, 4. We're going to do it for the PQ, which is 2, negative 1, and 5, 3. Do the same thing. And that's going to be 5 minus 2 is 3, and 3 minus negative 1 is 4. And basically what we're saying is both of these got to be the same vectors because they have the same components. And let's do the math. You can go at your own pace on this one. As you can see, that's what I just said earlier. And it's the same thing for PQ. Therefore, vector RS is equivalent to vector PQ. Here's just a way of looking at a head-to-tail form of adding and subtracting vectors. Vectors can be added or subtracted to create a new vector. Head-to-tail form of adding and subtracting vectors. This is a visual representation of it all. You see that's a vector. Let's just call it a yellow vector. You got a green vector. So if you add these two vectors, all you have to do is put the tail of the green vector at the head of the yellow vector, and you'll create the new vector, which is this. This is a new vector. Let's do another vector. You got a vector going down, a vector going up, like that. They seem to have the same size. So if you add these two vectors, you're gonna put the tail of the green vector at the tip or the head of the yellow vector, like this, and they undo each other. So there's no vector anymore. They undid each other. You got these two vectors, and if it tells you to add these vectors, put the tail of the green vector at the head of the yellow vector, and then go from the beginning of the vector to the end of the vector, and it'll be this, the equivalent vector. You could just go at your own pace looking at this, become repetitive. You can subtract vectors. You see this vector, I'm gonna draw the vector V first, and now saying to subtract vector W. Vector W is going down as well, but it's, since I'm subtracting it, it has to go the other way at the tip. So instead of continuing going down at the tip of the head of the yellow vector, it's gonna have to head the other way, up. And then that you see that's green, that's gonna be the equivalent vector, the actual result. That's the resultant vector. Again, this one's, they're gonna almost undo each other. One's going down, and actually they're not gonna undo each other, because as it is, the green one is going up, but the minus is making it go down, so it's actually gonna make it bigger. So it's gonna make a much bigger vector. There it is. All right, so we just do that. Continue on. Analytic form of adding, subtracting vectors. Find the component form and magnitude of the following vectors. So how do you find vector PR? Well, again, just subtract. Go look for P, look for R, subtract them. So it'd be 2 minus a negative 1. Then you got 5 minus 3. 2 minus a negative 1. It would be 3. 5 minus 3 is 2. So it'd be 3, 2 is the vector. Here, all you gotta do is plug in the QS. Well, it's a lot of work. B is gonna equal 2. Negative 2 is just a constant. Then you got QS. QS is 5, 3, negative 1, 6. So you're going to have to do this. You're going to do negative 1 minus 5 and then 6 minus 3. Then you're going to have the plus 1 half. Okay, plus 1 half. Then you're going to do PR, P, and R. 2 minus a negative 1 and then 5 minus 3. Simple arithmetic, you're going to do negative 1 minus 5 is negative 6. 6 minus 3 is 3. So that's going to be negative 2. We worked out the inside. Let's work the inside of the last part right there. So it'll be plus 1 half. 2 minus a negative 1 is 3. 5 minus 3 is 2. So it'll be 3, 2. Yeah, 3, 2. So 1 half, 3, 2. Distribute the negative 2. It'll be negative times negative 12. Positive 12, negative 6. Added to 3 halves and 1. Then you're going to add the x components and then the y components. That's going to be 13 and a half and then negative 5. Same thing with this. You can look at the website as we continue with this.